All right, 4.4 inequalities and triangles. First thing we're going to start off by ordering angles. And so the angles of a triangle can be put in order by comparing the sides. So if we look here, the smallest angle is always going to be the opposite of the smallest side. So in this case, if this side right here is the smallest, then that means the opposite of that is going to be angle A. Then you have the largest angle is always opposite the largest side. And so in this case, the largest side is this one right here where it's 13. And so the opposite angle to that would be angle B. So if I'm going to put these angles in order from least to greatest, that means the smallest one has to go first and then the largest one goes last. And so looking at the smallest side was 7. So therefore, the opposite angle was angle A, which has to be the smallest. Then I'm going to ignore the middle one for right now, but the greatest is going to be the opposite of the largest side. Well, the largest side was 13, so therefore the largest angle has to be angle B. And so to figure out what's left, well, the only one we have not used is angle C, so therefore that one has to go in the middle. And so if I look at the examples for 1 and 2, it practices the same concept. So we're going to order the angles in order from least to greatest. And so I'm going to start off by figuring out what is the smallest side. Well, I have 30, 35, and 38. 30 is the smallest side. So the opposite angle would be angle T. Then I look for the greatest side. So the greatest side in this case is 38. And so the opposite angle to that one would be angle S. You can kind of think of it as if 38 is the side RT, well, the only angle that I would not be using is S, so therefore that's the opposite. So you can kind of cover it up. So RS was here, that means T is the opposite. And then because we use angle T and angle S, that means angle R goes in the middle. And then example 2 says order the angles from greatest to least. So that means I need to start with the biggest one first. So in this case, for this triangle, side WY, which is 43 feet, is the largest. So therefore, the opposite angle would be angle X. Then I go to find the smallest side, which is XY, which is 26 feet. So therefore, the opposite would be angle W. And so if I've already used X and W, that means that angle Y has to go in the middle. Then you can also order by sides. And so in this case, the sides of a triangle can be put in order by comparing its angles. So it's the same concept. The shortest side is always opposite the smallest angle. And then the longest side is always opposite the largest angle. Well, in this case, for this triangle over here, we're wanting to order the sides from least to greatest. Well, if you notice in this triangle, I currently have 2 angles given, but I'm missing this third one. And so to find this angle right here, I would do 180 minus 103 minus 42 because all 3 of them should add up to 180. And this is going to give me 35 degrees. So now that I have all 3 angles, I can determine which is the sides that are from least to greatest. So to find the shortest side, I need to find the smallest angle. Well, in this case, that was this angle right here. And so the opposite side of that would be this side, which would be ED, or it can be written DE. So these order can be reversed, just as long as those 2 are the ones used. Then I'm going to find my greatest side by finding the largest angle. In this case, the largest angle is this one. The opposite side would be EF. And so in this case, EF is the longest side. So therefore, the only side that I have not used is this one down here, which is DF, or it can be written as FD. So you can practice this in examples 3 and 4. So in this one, we're going to order the sides from least to greatest. And so notice once again, I have a triangle with 2 angles given, but I need to find this third one. So to find this one, I would do 180 minus 31 minus 57, which is going to give me 92 degrees. Okay, so now that I have all 3 angles, I can start putting them in order based on their sides. So if I'm focusing on least to greatest, I'm going to find the smallest angle first, which in this case is 31. So therefore, the opposite side is going to be KL. Then I find the largest angle, which is 92, and the opposite for that one is going to be JL. Then that means the only one that's left that I have not used is this side right here, which would be referred to as JK or KJ. So example 4, we have 44. This symbol right here tells us that this is a 90-degree angle. And so to find the angle of E, I'm going to do 180 minus 44 minus 90, which equals 46. So this angle is 46 degrees. So now for these, I'm going to order the sides from greatest to least. So that means I'm going to start with the biggest angle first. So here is the biggest angle here. So the side opposite would be BE. Then I'm going to find the smallest angle, which in this case is this one here, which the side opposite would be DE or ED. So then the only one that I have not used is this side, which it would be BD. Now, sometimes you are not given the actual values and actually have to solve for them. So in example 5, it says list the angles and sides in order from least to greatest. So to start off with, I need to figure out what are these angled measures. And to do that, we're going to add all of these and then make them equal 180. Because all angles in a triangle should add up to 180. So I have 2x plus 3 plus x minus 1 plus x plus 6 equals 180. So if I combine like terms, I should be able to add these to get 4x. Then I should be able to combine my constants, which should give me positive 8. So I end up with 4x plus 8 equals 180. Now I'm going to solve for x. So I'm going to subtract 8 on both sides. This is gone because it equals 0. Now I have 4x equals 172. Divide by 4, and therefore x equals 43. So now that I have x equal to 43, I can take this value and substitute it in to each of these equations to find the measure of each angle. So 2 times 43 plus 3, this is going to give me 89. Then I have 43 minus 1 is going to give me 42. And then 43 plus 6 is going to give me 49. So now that I have all 3 angles, I can put these angles in order from least to greatest. So least angle is going to be angle P. Then the next biggest one is 49. So that means angle Q goes next. And the largest angle is angle M. And since I have angle P, Q, and M, I should be able to determine the sides that are in order from least to greatest. Well, in this case, the smallest one was 42. So therefore, the opposite side would be MQ. Then I have 49. The opposite of that is MP. And then the largest one was 89, which the opposite of that one is PQ. So here you have the angles and the sides in order from least to greatest. Now let's talk about the hinge theorem. Okay, now before I do that, so recall that this symbol, yes, it does look like an angle symbol, but as an inequality, it would represent less than, and then this symbol as an inequality would represent greater than. And so we're going to use those symbols to help us determine the hinge theorem and compare angles and sides. So here it says if two sides of a triangle are congruent to two sides of another triangle. That's basically saying this is congruent to this, and this is congruent to this. Then it says the included angle of the first, which we're going to say this is 80, is larger than the included angle of the second. We're going to say this one's 75. Well, in this case, the measure of angle A would be greater than the measure of angle D, because 80 is greater than 75. Then that means that the sides opposite also are going to be considered larger for one versus the other. So this side, okay, so BC has to be greater than this side of EF. So that's what this statement is saying. If this angle is larger than this angle, then this side has to be larger than this side. So let's practice this in examples 6, 7, and 8. We're going to compare the sides by filling in the blank with a less than or a greater than symbol. So here we have KL and PM. We're trying to compare these two. KL is right here and PM is right there. So to do this, we need to figure out, well, let's compare the angles. So the angle opposite of this side would be 79 degrees, and the angle opposite of this side would be 74. So when I compare these two, 79 is actually greater than 74, so therefore KL is greater than PM. Same thing with over here on number 7. We're going to compare PQ to PS. PQ is right here, and then PS is right here. Well, notice PS, we do know the opposite angle, which is 83 degrees, but I'm missing this opposite angle. And so to find this, I can see that these two angles form a linear pair. And if you recall, a linear pair is supplementary, means it adds to 180. So I'm going to do 180 minus 83, which is going to give me 97. So therefore, this angle right here is 97 degrees. So I can see that PQ, this angle 97 is greater than 83. So therefore, PQ is greater than PS. Example 8, we're comparing WX, okay? I can see there that this opposite angle would be 53 because I'm only focusing on that triangle, okay? It's not the entire thing. It's not 93. It's just that triangle. So WX has an opposite angle of 53, and then XY is this one right here. Well, I can see that I have these two angles, but I'm missing this one. So similar to previous page, when you add angles together, it should equal 180. So I'm going to do 180 minus 93 minus 32, which should give me 55. So that means that this angle right here is the opposite angle, which should be 55. Well, if I compare these, 53 is less than 55, so side WX is less than XY. Now let's go back and look at the converse of a hinge theorem. So it's basically switching it around. If two sides of a triangle are congruent to two sides of another triangle, so same thing, these are congruent and these are congruent, and the side opposite of the angle, include the angle as the first is larger than the second. So we're going to say this is 10 and this is 8. That means if this side, BC, is greater than this side, EF, then that means that this angle, so the measure of angle A, has to be greater than this angle, the measure of angle D. So notice we're just basically switching these around. And that's only if you're given the sides and then trying to compare the angles. So if you look at number 9, we have the measure of angle D compared to the measure of angle H. So here's angle D. So in order to compare these, I'm going to look at the opposite sides. So the opposite side for angle D would be 35 from E to F. And then over here for H, here's H, the opposite side for this would be 33. Well, when I compare 35 to 33, that's greater. So therefore, a measure of angle D has to be greater than the measure of angle H based off of the theorem. Example 9. You have the measure of angle A and the measure of angle E. Well, the measure of angle A would be right here. So the opposite of that one would be 16. And the measure of angle E, which is right here, the opposite side of that would be 15. When I compare, 16 is greater than 15, so therefore the measure of angle A is greater than the measure of angle E. All right, last one. We have the measure of RSQ. So notice this one's a little bit different, but it still tells me the angle. So RSQ, here's R, here's S, here's Q. S would be considered my vertex angle. So therefore, I am focusing on this angle right here. Well, the opposite side of this angle would be 13. Then TQS, so here's T, here's Q, here's S. So that means this Q is my vertex angle. So therefore, the opposite side for this one would be 14. And so therefore, if I compare 13 is less than 14, so measure of angle RSQ is less than the measure of angle TQS.